Welcome to AI Decoded, the podcast where we pull back the curtain on artificial intelligence, making sense of the complex and bringing it down to earth. I'm Alex.
And I'm Sam. In every episode, we'll break down the buzzwords, explore the core concepts, and show you how AI is actually built and used.
Today, for our very first episode, we're tackling a fundamental question. What exactly is an AI model? Is it just code? Is it some sort of magic? We're going to demystify it all.
Yeah, I think that's where a lot of people get stuck. We hear AI model all the time, but what's actually inside that black box?
Excellent point, Sam. Let's tackle that head on. An AI model isn't just lines of code you write from scratch to do a specific task, like if this, then that. Instead, think of an AI model as the outcome of a learning process. It starts as an algorithm, a blueprint, an empty structure. Then you feed it massive amounts of data. That's the training part. During this training, the model adjusts its internal mathematical parameters. And those parameters, they are the learned knowledge. They are literally millions, even billions of numerical values, weights, and biases that the AI has optimized to recognize patterns, make decisions, or generate content. So no, it's not just the code for the algorithm, it's the learned numbers that the algorithm has found.
So the code defines how it learns, but the trained model is the actual knowledge stored as those numbers? That makes so much more sense.
Precisely. And today, we're going to prove that by walking through a practical example, building an AI to predict customer churn. That's when a customer stops using a service. We'll use two Python files, trainchurnmodel.py for the learning part and predictchurn.py for applying that learning. Teaching the AI with trainchurnmodel.py. All right, let's open up trainchurnmodel.py. This script is all about teaching our AI. We start with our import statements. Listen closely to the tools we're bringing in. Import pandas as PD, import numpy as NP, from sklearn.modelSelection import train-test-split, from sklearn.linearModel import logistic regression, import joblib. So, pandas, or PD, is for working with data tables, like spreadsheets. NumPy, or NP, helps us with numerical operations, especially on arrays of numbers. From scikit-learn, we're getting train-test-split to divide our data, and logistic regression, which is the actual AI algorithm we're using. And finally, joblib is our special tool for saving and loading our trained AI model. So, pandas, or PD, is for working with data tables, like spreadsheets. NumPy, or NP, helps us with numerical operations, especially on arrays of numbers. From scikit-learn, we're getting train-test-split to divide our data, and logistic regression, which is the actual AI algorithm we're using. And finally, joblib is our special tool for saving and loading our trained AI model. Next, we simulate having customer data, things like their age and monthly bill. In a real company, this data would be collected over time. For our demo, we just generate 500 fake customers and even assign whether they're likely to churn based on age and bill. We then separate this data into what the AI will learn from, called features, stored in X, and what it needs to predict, called the target, stored in Y. The code for that looks like this. X equals df.age, monthly bill. Y equals df.churn. Then, a crucial step, we split it into a training set and a testing set using train-test-split. Xtrain, Xtest, Ytrain, Ytest equals train-test-split, X, Y, test size equals 0.2, random state equals 42. So, the AI learns from one set of data and then gets tested on data it hasn't seen yet to make sure it's actually learned, not just memorized. Smart. And that's a perfect lead-in, Sam. What we're doing here, training with labeled examples like age, bill, and churn status, is called supervised learning.
Supervised learning?
So the AI has a supervisor telling it the right answers during training?
Exactly. We supervise its learning by giving it inputs and their corresponding correct outputs. It's like teaching a child with flashcards. This is a cat. This is a dog. The goal is to predict that specific known outcome. Now, there's another main type called unsupervised learning.
Unsupervised, so no answers given?
Right. With unsupervised learning, the data has no labels. The AI's job is to find hidden patterns, structures, or groupings on its own. Think of it clustering customers into different segments without being told beforehand what those segments are. But for our churn prediction, it's definitely supervised. Then comes the core of training, the line model.fit xtrain, ytrain. Here, our chosen AI algorithm, logistic regression, works its magic. It looks at the ages and bills in the training data and mathematically figures out the relationship that best predicts churn. The code to initialize and fit the model is model equals logistic regression, random state equals 42. Model.fit xtrain, ytrain. The result of this learning isn't more code. It's a set of numbers. We get coefficients. These are like weights, telling us how much age and monthly bill influence churn, and an intercept, which is a baseline value. These numbers are the AI's learned knowledge. They literally embody the trained AI model. Finally, we save this entire trained model using joblib.dump into a file named churnpredictormodel.joblib. The code looks like this. Model file name equals churnpredictormodel.joblib, joblib.dump model file. This file now contains all those learned numerical parameters. It's portable.
So that .joblib file is our complete self-contained AI brain for churn prediction.
That's right. It's the data representing the model's learned relationship ready for action. Phase 2, putting the AI to work with predictchurn.py. Now that we have our churn predictor model.joblib file, let's move to predictchurn.py. This script shows how we use our saved model. Again, we start with imports. Import pandas as PD, import joblib, import OS. We already know pandas and joblib. OS is new. It helps us interact with the operating system, like checking if a file exists. The first thing it does is check if our churn predictor model.joblib file actually exists. If it does, we use joblib.load to bring that file with all its learned numerical parameters back into our Python program's memory. The code for loading is loaditModel equals joblib.load model file name. The AI's knowledge is now active and ready.
So no retraining needed? Just load and go?
Exactly. Once loaded, we prepare some new customer data, customers the model has never seen. We make sure this data has the same structure, age and monthly bill. The code defines this new data and puts it into a pandas data frame. New customers data equals age 3560, monthly bill 75.0, 110.5. New customers df equals pd.dataframe, new customers data. Then the moment of truth, loaditModel.predict and loaditModel.predict probability. These lines tell our loaded AI to use its learned knowledge to make a prediction for each new customer. Predictions equals loaditModel.predict new customers DF. Predict probabilities equals loaditModel.predict probability new customers DF. Predict gives us a simple churn or no churn, while predict probability gives us the likelihood or probability of them churning. Finally, we print out these predictions and probabilities for each customer. This shows how that collection of numbers we saved during training can now provide valuable insights about new, unseen data.
That's really powerful. From raw data to a trained brain, and then using that brain to forecast customer behavior.
It truly is. This demonstrates the full cycle, how machine learning models learn patterns from data, encapsulate that learning into a saved file, and then apply that knowledge to make real-world predictions. This is the core of AI in action. And that brings us to the end of our very first episode of AI Decoded. We hope this has clarified what an AI model is and how it powers everyday predictions. And that brings us to the end of our very first episode of AI Decoded. We truly hope this conversation has shed some light on what an AI model actually is and sparked your curiosity about the fascinating world of artificial intelligence.
Absolutely, Sam. It's just the beginning of our journey together. In our next episode, we'll be diving into the very basics of AI, laying the groundwork for understanding more complex concepts down the line. We hope today's discussion has inspired you to continue learning with us.
We're so excited to have you join us on this exploration. If you enjoyed this episode and want to hear more, please subscribe to our channel. Your support helps us bring you more insights into the world of AI.
Thank you for tuning in to AI Decoded. We look forward to unraveling more of the AI universe with you next time.